All right, 8.3, filling and emptying tanks. Tank A initially contained 124 liters of water. It is then filled with more water at a constant rate of 9 liters per minute. How many liters of water are in tank A after the following amounts of time have passed? All right, here's a classic problem that we've kind of dealt with over a number of times where we have an original initial amount, a beginning amount. Remember this word initially means the beginning. And then we're like adding or subtracting an amount for each, in this case, minute. And we're adding, in this case, a certain amount of water per minute. So let's go through and think through that. All right, so we've got 124 liters of water originally, beginning with that amount. And then we're adding 9 liters per minute. So in this case, we're adding 9 liters over 4 minutes. So 9 times 4 would be 36, and then we're going to add that to the original amount. So 36 plus 124, 124 plus 9 times 4 will be 160 liters of water. So the next one says, okay, what if we had 90 seconds? Now be careful with this one, right? We don't want to plug in 90 because our variable is related to liters per minute, where our variable is minutes here, and 90 seconds is not minutes. 90 seconds, though, you guys know 60 seconds in a minute, so 90 seconds, 90 divided by 60 would be 1.5 minutes. So that's what we're going to use for our variable. So once again, we had 124, and we're going to do 9 liters over 1.5 minutes this time. So we're not going to add that many liters, but that's going to be, what, about 13.5, or exactly 13.5. So that brings us up to a total of 137.5 liters. All right, and so let's make a calculation then, or an equation for m minutes. All right, so let's highlight our variables here. So m minutes, all right, so here's the number of minutes that we had. So m's going to go in that spot right there, right? And the other bits that are staying the same, the other pieces that are staying the same here would be the 124 and the 9 liters per minute is staying the same, but we just are going to change up the amount of minutes. And then that is going to be equal to the total liters. So it doesn't look like they're giving us a variable here, but I'll just put liters, maybe total liters, liters total. And so the variable that we have here is that m variable right here. So 124 plus 9m will give us our total number of liters. All right, let's look at the next one. How many minutes have passed m when tank A contains the following amount of water? Okay, so now we have 151 liters. We know we started with 124. So what's that difference? How much just got added on here? Well, I'll actually reverse that. Let's subtract. And so we now know that 27 liters have been added. That's not what we want to find. We want to find the number of minutes that have passed. All right, so if 27 liters have been added, and we know the rate is 9 liters per minute, that means that it must have taken 27 divided by 9, or 3 minutes for that to happen. If we were all the way up to 191.5, well, let's see. Subtract our original amount, that gets us 67.5 liters added. Again, let's remember that's the amount that's been added on at 9 liters per minute. So 67.5 liters divided by 9 liters per minute gets us 7.5 minutes that took. All right, so let's change this into an equation again. So notice what is changing up here, p liters. So each one of these times we're really taking, and the p liters was our amount at the end, and so then we were trying to kind of use that, subtract that to figure out how many liters were added. and then we eventually figured out how many minutes were left. So we always took, oops, let's use the right variables here. So we took the P liters and we subtracted off our original amount. We got that amount, and then we took that amount, we'd always divided it by 9 liters per minute. And then that would result in the total amount of minutes. So we'll call that M, as we're told up here. So let's just highlight that again. I think we had used red for our M highlights. So the number of minutes here was this amount. That's what we ended up at the end. And our P liters was the amount here. And so once again, we have a couple of equations that are equivalent to each other, but have solved for different variables. So these two equations right here are equivalent to each other, but notice that the one in number 1C solves for the liters, and the one in 2C solves for the amount of minutes. So if we were interested in minutes, we would use the 2C equation. If we were interested in the amount of liters, we would use the 1C equation. But they are equivalent to each other. You go through the algebraic steps, you can change from one equation to the other. All right, number 3. Tank B, which initially contains 80 liters of water, is being drained at a rate of 2.5 liters per minute. How many liters remain in the tank after following amounts of time? All right, so notice it's draining. We have an original amount, it's draining, so we're actually subtracting the water this time in amount per minute. Once again, though, 30 seconds, be careful with that. 30 seconds is 1/2 of a minute, right? So if we're using that idea. So we started off with 80. This time we're subtracting 2.5 liters per minute over 1/2 a minute. All right, so in other words, we're subtracting 1.25 liters, and that gets us down to 78.75 liters. And the next one, 80, and then this time we're subtracting 2.5 liters over 7 minutes. So in other words, 2.5 times 7 is 17.5, so we're subtracting that off, and we're left with 62.5 liters that are left. So each one of these times, what's changing up is the amount of minutes. So we have 80 as the original amount. We're always subtracting 2.5 liters per minute, so T minutes. And then that will give us our liters that are remaining. And so in that case, we solve for the liters remaining. The calculation 80 minus 2.5 T gives us our liters remaining. All right. And finally, number 4, for how many minutes T has the water been draining when the tank B contains the following amounts of water? All right, so it's kind of like what we were doing up in number 2, right? So if we started with 80 and we ended up with 75, that must mean that we subtracted 5 liters off. And so 5 liters, how many minutes did it take to drain 5 liters? Well, at 2.5 liters per minute, that means it took 2 minutes. 5 divided by 2.5. If we got down to 32.5 liters, that means that 47.5 liters were drained. And so 47.5 liters divided by 2.5 liters per minute, and that comes out to 19 minutes. So V liters have been drained here, and so in each one of the calculations of variable V meters, we're subtracting off the V liters. And then we're taking that number and always dividing it by 2.5. And then that gives us the amount of minutes, t. Up here, we're looking for the amount of minutes that would be equal to t. So once again, we have two equations here in 3c and 4c that are equivalent to each other. They represent the same information, same variables, same constants, but one has been solved for our liters remaining here, and the other one has been solved for the amount of time. So rearranging the variables, we can get, in fact, if this variable up here, I guess, was v in the problem below. So this one has v is equal to 80 minus 2.5t, where the one in 4c is t is equal to 80 minus v divided by 2.5. So equivalent equations, just with different variables that have been solved for. So if we're interested in liters remaining, we'll use the equation from 3c. If we're interested in the time,